Let's get started with our next keynote. Today we have with us Bentsi Ben-atar, CMO at Sepio. He will be talking about case study analysis, why complete access visibility should be one of your vitals. Please feel free to post any questions you may have, and we will do our best to answer them before the session ends. So I'll hand over to you now, Bentsi. Hello, Bentsi, how are you?
Hello, Jose, how are you?
Well, not too bad. Glad to have you aboard. So I'm very excited about your keynote, your case study analysis, talking about why complete access visibility should be one of your vitals. So please, sir, go ahead. You know the process.
Yeah.
Please share your slide deck. I'm going to be supporting you until we are sure that everything is under control.
Sure. So let's start. Okay.
You are ready to go. Perfect.
Very good. Great. So thank you for those who joined in. My name is Bentsi. I'm one of the co-founders for Sepio, a company that manages hardware-related risks. And I'll be presenting kind of an intro to hardware access control by kind of analyzing and presenting the case study from one of our partners who was willing to come forward by name. And the presentation is titled "Check Your Assets Vitals," and hopefully by the end of this presentation you'll completely understand why. So those of you who've been in past events or webinars that I did, so you know that I like videos and I like a demo, so you'll be getting both of them. And first I want to share with you like two short clips that I've titled "The Good, the Bad, and the Ugly," and they actually address two main issues when dealing with the healthcare visibility issues. One is the visibility and asset inventory of all devices, and the second is the issue of rogue device mitigation and the never-ending fight to avoid breaches of various kinds. So let's move into the first video. First, let's do this. Great. So let's start with this one.
One of the largest hospitals in the country was hit by a ransomware attack. The hospital went through a series of cybersecurity audits where they scored low only with regards to their hardware access control measures. Yet it is still unclear how the attackers got in.
Okay, so this video actually illustrated a ransomware attack being carried out by a rubber ducky, which is a HID attack tool that impersonates as a legitimate HID device, as a legitimate keyboard, and by doing that, being completely authentic on the virtual plane with regards to its vendor ID, product ID, class ID, everything about this device says that it's authentic, other than the fact that it is not. So that's the bad part of the good and the bad. Let's turn into the good aspects of asset visibility, and that relates to the budget planning and an asset inventory of those devices. And this is something that we hear from different CISOs struggling with budget planning. And obviously, when you want to do an accurate budget planning, you need to know what are your assets, even if with regards to cybersecurity expenses. How many licenses do you buy? Which equipment should be replaced, and how many of those seats for those maintenance contract you need to renew. And in most cases, you get a very rough estimate for that data. And in that case, there's a clear kind of ROI on achieving visibility, because once you actually know what are the exact numbers that you have, you can actually go ahead and negotiate better pricing terms, better handling of your life cycle of your various devices, and so on. So I think that you get the overall message here that having a clear picture of the assets has a significant value. And later on, I'll elaborate of how we at Sepio are doing this in a different and unique way to generate that ultimate visibility. So going back to the presentation. So healthcare poses unique challenges with regards to cybersecurity. You know, probably it's stating the obvious, but it is obviously highly targeted because there's a variety of crown jewels. Crown jewels could be a confidential information, which may include visuals of an aesthetic clinic with taking pictures of the before and after. It could be billing and financial data. It could be research that is being held with significant impact and significant IP in that medical facility. So there's a lot of crown jewels that you need to protect. The second one is having a requirement for strict operational continuity. You know, having an MRI machine being shut down, or an X-ray, or God forbid, life supporting a machine has a significant life-threatening impact, and we've seen that in the last couple of years that some of the incidents that related physical impact on devices had a tragic outcome. The fact that there's a large variety of devices also poses a significant challenge, because you have a small devices, which could be, let's say, oxygen generators or pulse oximeters, or very simple looking device, and you have the expensive devices. You have the X-ray machine, you have the MRI. There are different types of devices with different capabilities, security-wise and functionality-wise and connectivity-wise. And that large variety of devices imposes a lot of challenges on the security teams. Another challenge is what I call the physician's challenge. In a lot of healthcare operators, there are kind of physicians that they can work locally or remotely. In most cases, they will use their own equipment, which in most cases will be uncontrolled. In some cases, they will be less informed and less, I might say, obedient to the cybersecurity rules that the enterprise may impose on its a kind of standard employees. There's the issue of wandering assets. So wandering assets is, you know, in a hospital, and I think that you've seen that in the video as well. Equipment is being moved around from place to place. So the same way that there's a concept called patient wandering, where you actually look for certain patients that are in between transit between various departments in the hospital. The same applies to an asset. An oxygen generator could be in one place, and then it could be in another place. So having full control and knowing the whereabouts of every device or every asset is something that is of a challenge. And uncontrolled physical access is a hospital in general. It consists of multiple entities with different and varying degrees of cybersecurity awareness. So you have the obviously the patients themselves, you have the personnel, you have visitors, you have suppliers of the food, suppliers of hygiene products, you have suppliers of medical equipment, contractors, maintenance guys. So there's a lot of human kind of traffic in the hospital with very little control compared with, let's say, a bank headquarter or a federal entity or something similar of that nature. So obviously there's a lot of challenges, and these challenges obviously turn the healthcare into the #1 targeted vertical in the US with regards to the number of events, and we've all heard about that. Now, but when we look into the actual relevancy of the hardware assets within all those challenges, we see a very strong connection between those challenges that previously stated and with regard to the specifics of hardware assets. And in most cases, in a healthcare environment, all unidentified devices are considered rogue. So that means that when you have a device that you cannot identify and you cannot pinpoint its owner and its characteristics and its vendor and its make and all the details about this device, then from your perspective, it should be considered a rogue device because you don't know anything about it. The second thing is the budget planning. Obviously, like in any other case, and especially in the COVID era, the issue of budget is extremely important, and you need to know what are your hardware assets, because in most cases the hardware assets are a considerable amount of your budget, and if you have a 50 X-ray machines or 61 X-ray machine, that's a significant difference and has a significant impact. So knowing exactly what you have is extremely important with regards to assets. Is extremely important for your budget planning. Emerging attack surface. When you talk about the bad part of hardware security and the fact that the rogue devices are being used as attack vehicles, and this is mainly due to the fact that attackers are being pushed by the kind of cybersecurity industry, by the fact that other aspects of cybersecurity layers up to the application layers are being handled quite in a quite tight way. And the fact that the hardware domain has been left unattended in most cases kind of pushes the attackers to find alternative paths, and using a hardware asset like a rubber ducky or a network implant or something like that, or a ninja cable, is something that is extremely lucrative for the potential attacker. Hardware assets resonates well with the healthcare human profile, as you've seen in the video. You know, you need only a couple of seconds of kind of unaware a nurse in the nurse station or something like that. The number of times that I've stepped into hospitals and I saw someone charging their phone in the mobile nursing station or something like that, although they shouldn't have, is something that, you know, you need only an open USB for a couple of seconds, and that's it. You have network devices spread around. So the fact that this human profiling of people going in and out with different characteristics allows them easy access to the various devices. And the last one with regards to hardware assets is the fact that there's significant restrictions and limitation with regards to FDA and security patches. So obviously, certifying a medical device is an extremely painful process. And when you want to change something within the security domain or in the firmware of that device, and obviously security aspects is in most cases deals with the core of the operating system or the core device, and then there's the issue: do you resubmit it to the FDA or not? And there's a reluctance in most cases to try to avoid kind of licensing again or regulating again the devices. So that leaves a lot of devices with legacy operating systems, with known vulnerability and lack of security patches for those devices. So let's do just a quick demo just to show you how easy it is. And in order to do so, I'll be using our good friend here, the rubber ducky. In this case, the rubber ducky impersonates as a Microsoft keyboard, legitimate keyboard, 45E as the vendor. I'm running an endpoint security, one of the, according to Gartner, one of the top 2, and just look and see what happens when I plug this in. And as you can see, you don't need to be an expert, in coding or something like that. You just need the access, and everything that a local user can do on their keyboard, this device can do the same, including some evasive measures, to try to hide the fact that it's an automated tool and not a human being. And in this case, there's a folder that's being encrypted on my machine. You get a pop-up, and then practically your day is ruined. And it's that easy. You don't, my mother could actually run this attack as well. So it's very easy and very simple to run these type of attacks. So once we've proven that, let's talk about Baptist Health. So Baptist Health is one of our partners. It's a healthcare operator. It has about 20,000 employees, about 330,000 connected devices, 400 points of care, spread over 4 states. And I think that they're reasonably considered being the forefront of cybersecurity technologies, with their very talented and evangelizing CISO of Michael Erickson. And I've put together a couple of quotes that we got from various interviews that Baptist security team held with the public media, and wanted to focus on things that they saw and they've observed, and they concluded a certain conclusion. I want to go through that. So the first thing is, why now? Why deal with the hardware security issues now? And going back to one of the aspects, which is the bad aspect, is the increase in the number of low cost and highly effective tools. And I think that there was just a recent show with Dr. Phil showing where Kevin showed a USB Ninja, a standard looking charging cable, look like benign peripheral devices. And these devices can cause significant damage. And the most important about these devices is that they go undetected by existing classic security products, whether it's an endpoint security or DLP solutions on the peripheral side, or if it's on the network side, like network implants, many in the middle attacks and others. So the fact that these devices are becoming so available and and they are so low cost, usually I go into AliExpress the website and write bad USB, and then you will see how many tools and their ridiculous pricing are offered for such a simple yet lethal capability. The second thing is about visibility and creating a return on investment. So obviously, in most cases, when you talk about cybersecurity, it's about prevention and business continuity, and in most cases you don't look at it as a source of actually generating a certain return on investment. In most cases, the mere fact that your enterprise hasn't been breached, or you were able to block certain attacks, that's good enough. But in this case, the fact that you can generate ultimate visibility to everything that's connected, whether it's managed or unmanaged, provides better business decision to the management, because you actually know what you have. And if someone tells you, oh, we need another 50 of those and we need another 200 of those, and then you ask them, okay, how many do you have now? And if before the answer was kind of puzzling or providing an estimate, now you know what is the exact number of devices that you have. And the fact that you have these new set of information, of reliable information and real-time information to the asset inventory, it helps better planning, better life cycle of assets, especially due to the fact that some of these assets are extremely expensive, and sometimes are very hard to find. Some of them are legacy assets that you need to take a very good record of those devices, making sure that you have enough of. So the fact that you have a better understanding and better visibility to the devices that you have actually translates to the bottom line of a more optimal expenditure of your and use of your budgets. Another thing, and this is something that healthcare operators and cybersecurity teams in all around the world and various verticals is, obviously everybody are short in human resources. They want a very easy deployment phase without too much of intervention and requirements from the existing security team, which is already overswamped with work. And when we deployed the HackOne solution, which I'll elaborate in a minute, it was a really lightweight effort and simple to install. Within less than 24 hours, we were able to get everything up and running, and with a very low cost of ownership. So you don't need to add stuff for it. So let's talk about the new data source that we can actually harness into our goal of achieving ultimate visibility and understanding what are our assets, applying different policy enforcement rules, and mitigating those bad devices. So if you look into the existing security product out there, you'll see that there's a lot of security products starting from layer 2 and above up to the application layer. Now, obviously, potential attackers see the same view, the same OSI layer model, and they see that there's a lot of security products out there. So if security now starts in layer 2, because you first need to have the MAC address in order to sniff out traffic and to understand what are the entities that are currently connected, then obviously that pushes them into the physical layer. And in that physical layer, until now, it was extremely unattended. The same goes for kind of professional spoofing devices, but these are not only for those devices that are rogue devices, but again, all unidentified devices that might be passive in nature, or are unmanaged devices that do not have a MAC address or any identities in the upper layers. You want to identify those as well. And the fact that you can now, using a physical layer fingerprinting techniques, you can go down to the layer 1, provides a new data source and opens up a new visibility into areas that were previously unexplored. On top of obviously reporting all those devices that are out there and are connected layer 2 and above. So seeing invisible unmanaged assets, again, fasten these in. With that respect, the fact that you can use physical layer data means that you don't need to rely on traffic monitoring, which relying on traffic monitoring is both an issue in the deployment, because then you need to do port mirroring, you need to drive the traffic into probes or to your appliances. There are significant privacy issues, because that means that when you monitor the traffic, then you see all the data that flows into it, encrypted or not, and that applies a significant restriction with regards to HIPAA. So the fact that you do not need to monitor the traffic makes it a very easy and fast deployment, and doesn't require any privacy issues whatsoever. The fact that the physical layer is a fingerprinting is something that is persistent with the device and appears at all time, means that you don't need to apply a baseline for those devices and for the detection of it. If the device is there, then you will see its physical layer fingerprinting, and then you can create various policies of denial or allow list for those devices. As mentioned before, no privileged data is shared. So, HIPAA-wise and other regulation-wise, your life are easier. And you can provide and apply different policies and different actions according to the risks. And this resonates extremely well with the concept of zero trust, which deals with the device identification and risk scoring for various devices. So the fact that you can identify and trail every device within the enterprise and provide the risks for it, first of all, lets you focus on those devices that actually need your attention. It lets you do that in an automated way, so that you can integrate that data with external source solution or SIM solution. The core data source for this, for making this possible, is the hardware fingerprinting. So the hardware fingerprinting is actually collecting data from layer one. So layer one, if we talked about the networking, is actually the file layer from the switch. So you could actually collect the data from the switch using SSH, just SSHing to the switch, extracting the file layer using read-only commands, and then you get the physical layer a characteristic of that device, which is a digital representation of the voltage, of equalizer coefficients, of sometimes jitter, sometimes eye patterns of the signals, and all of that. And all this data can be generated into a single vector that we call the physical layer fingerprinting. And that physical layer fingerprinting kind of identifies the device. It is dependent on the specifics of that device. So if device has been built in a certain way, then it will create a physical fingerprinting in a certain way. So a Starland tap will have a certain physical fingerprint, an unmanaged switch up will be a different, a Raspberry Pi a third one, and so on. Once we have that physical layer fingerprinting, then we can group those devices according to their identifications and fingerprints, and then we can provide the risk score for every device. So some devices are known to be, for example, invisible. For example, if we identify a tap in the network, then that obviously is something that's worth alerting on. If we find a Raspberry Pi as a man-in-the-middle attack spoofing a legitimate machine, then that obviously is an important alarm trigger, and it will get a high risk score. And when you collect all of those, and you either alert on them on standard alerting mechanism, or you integrate it through the SOAR and SIM solution, then you get a complete end-to-end analysis and mitigation of those risky or unknown devices. Obviously, we do not assume that we are familiar with all devices. So it's not like that, we rely only on previously fingerprinted devices. We understand that there are known unknowns. And for that, we have our own machine learning based algorithm that kicks in when we identify a device that was previously unknown, and then we use that algorithm to highlight those devices that have the higher risk scoring within those devices. So to conclude, that the highlights for that would be that physical layer fingerprinting doesn't require traffic monitoring, no privacy issues, and extremely fast, lightweight, and accurate. Just a bit about our solution. So our solution is called Hack One. It can be run on-prem, offline, or as an online SaaS solution on our Sepio cloud. And as I mentioned, we integrate with the network infrastructure using a SSH read-only commands. So we do not configure, we do not change anything in the switches. We do not cause any significant burden on the network performance itself. It's a very lightweight queries from the networking infrastructure itself, wireless and wired, Ethernet included. And for the endpoint side, we can run in a fixed agent mode, or in a agentless, or in a zero trust environment for kind of a hybrid environments that we're seeing. All this raw metadata is fed into the physical fingerprinting, machine learning, and big data algorithm that identifies the device and provides the risk scoring for it, and integrates with the external solution either through a dedicated API or through a standard REST API. A couple of two examples that we've seen, both on one includes a network man-in-the-middle implant using a standard off-the-shelf legitimate device, in this case a Pocket Port 2 device, which impersonates as a legitimate cable, and the other one is a bad USB being used as a as an air gap hopper over a sensitive air gap networks. The HackOne solution and the Sepio solution in general fits to any program, whether it's a CMDB or Zero Trust, or whether you have a NAC or you do not have a NAC. If you have a SOC, a SOAR, or SIM solution, whatever you have, we can integrate with it through a dedicated interface or through a general REST API interface. And as I mentioned, it's an extremely lightweight and effortless solution. With that, I'll have a quick peek at the chats just to make sure that. Okay. Okay. So with regards to IoT and IoT devices in general, so we do not install anything on any of the devices. And for those IoT and IoT devices that are located over there, they will be categorized and listed and added to the inventory per their physical layer characteristics that we get through the network interface from the network PHY interface of the switches that they are connected to.
Okay, thank you very much, Bentsi. It has been a very interesting presentation. I encourage the audience to reach out directly to Sepio, or they can reach out to us, and I'm gonna gladly put you guys in touch. Thank you, sir. Appreciate it.
Thank you very much. Have a great day. Bye-bye.
Bye.